So having looked at lists, we're going to look at tuples now. Pretty much just get a good grip on them so that we can not be burdened by misunderstanding what's going on with our data structures when we're trying to learn more complex topics or just trying to get some more interesting work done. So tuples are a data structure that is immutable, which is a really important characteristic. The fact that they're immutable means that their contents cannot be changed once they've been created. So for example, if I create, let's just see if I have, okay, so I have a tuple here, you know it's a tuple when it has round brackets and it's has its parentheses, rather, it's contained by parentheses and each element is separated by comma. And so, for example, you can do indexing on a tuple. If I'd say tup0, we get 1, etc. Tup1, 2, etc. So the difference here when we're talking about mutability is that you cannot change an individual element. It's not possible. So if I go to say tup0 equals a, as you can see it says error, tuple object does not support item assignment. And that's as opposed to a list. Let's say if I had a list, square bracket, 1, 2, 3, and then I said ls 0 equals, and I just try and assign a to that, that goes. That went just fine. It overrode it. So with a tuple, you cannot do that. So it's immutable. So another thing to know is that what defines a tuple is the comma rather than the parentheses. So if I go tup equals 1, 2, and then I print that out, now you'll see it prints out with the parentheses, but in fact it did create a tuple just having the comma. So you can create a tuple with a single data point using just whatever data point you want to add and then a comma. So that could be a function if you wanted it to be, for example, tup equals len. So similar to lists, the tuple can hold just about whatever you might need it to hold. So you can define an empty tuple with just the brackets. So I could say empty tuple is equal to these. And you can see it's empty because if you take the length, that's 0. So you know it's empty. You can cast another sequence type into a tuple using the tuple function. So I just made a list, right, ls. So if I use the tuple function and pass ls into it, now you see the square brackets have simply changed to round brackets. So the data structure is now a tuple, and that carries with it obviously the relevant details like immutability and other things. So the tuple has a couple of its own methods, just a couple. Whereas the list had a whole bunch, as we saw up here in the previous video, the tuple just has 2 methods that are defined exclusively for it. These are the count. So let me do this. Let me do the following. Let me say a list is equal, let me say it's an empty list, and then I'll do ls.expand or extend rather, it's the extend function I saw. Extend, and I'll add cheesecake. Now that's my list. So now I can pass this into a tuple. So tup equals tuple ls, my list. So now I have cheesecake in a tuple. So you can see how just because you can't add things to it if it's a tuple, you can quickly create whatever tuple you want by making it as a list, if that extend or append, whatever kind of function is more useful to you, method rather, and then cast it into a tuple. So now that I have this, we can see how it has the same count method as the list did. So if I count how many times the character E appears in cheesecake, it appeared 4 times. And I can count how many times capital C appeared twice. So letters are case sensitive, so you see there's no lowercase c. So that's how the count method works, like we saw last time. And similarly, there's the index method, which allows it returns the index at which the character appears. So the first S appears at index 4, 0 is C, 1 H, 2 E, 3 E, 4 S. So that returns the index, which you could then use. So let me try something here. We could say tup, and I'm going to open my indexing square bracket, and I'll say tup.index, and I'll say k plus 1. See what happens. So I went to k, we got the index value for k, and then we added 1 to it, so I went to the following character, which was an e. So I printed out an e. So if you didn't know what was beside a given element within your tuple, you could search up the index, something like that. Obviously, the power in all of this coding stuff is when you use functions together in such a way where the output of one function is the input of another one, and that kind of thing. So tuples also have a special kind of characteristic to them, which is the following. You can do tuple assignment. So I can create 2 variables here, I believe, and say that these are equal to 1, 2. And now if I go A, it says 1, B is equal to 2. So what just happened is you can use a tuple to assign multiple variables at the same time. And you do that by just having multiple variables on the left and a tuple of the same size on the right. So that could also be something else. Let me just say right now, let's just choose. Let me just make ls equal to 157. So we could have another multiple assignment going on here. A, B, C equals to 157 equals ls. And you see how, because ls stores a tuple that's the same size, as that is, it has 3 elements. Now we've done a triple assignment. So this kind of thing can be very, very handy. Now that's all in terms of methods for the tuple object. There's only index and count. So what I figured I would do in this video is that I would go through some other general functions that apply to any sequence type object type. So these functions we're going to look at now work for both lists and tuples, as well as some other sequence types. So we're going to see some repeat that we saw last time for lists. So let's look at it. So we have any. So there's a function here, any, that takes in a tuple, and if any value within that tuple is equal to true, then the output of any is true. So you could use it in something like this. You could say if any, and then you could have multiple logical statements such as A equals B, B equals to C, or ls 1 or the 0th index is, and we could just pass that in and see what that value is. So this is our if statement, then we can print something as true. Something is true in that list. Oh, my mistake. So as you can see, it gave an error, which is that any takes only exactly 1 argument, and 3 were given. So really, you have to implement, put in an iterator, an iterable. So I could put these in a list, and then it will iterate through that list. So now we can see that at least one of those 3 statements is true. We know that it's the first element of ls because that's a 1, and 1 is equal to true. So if we said if any, and then we can make a list here, true, false, false, we see this will give us a true. A little typo there. So basically it just allows you to use, you can use the any function instead of a bunch of or statements. So if this is true, or this is true, or this is true, you could just use if any of these are true and put all your statements in there. So that works for tuples as well as lists. I was just using tuple. I was just using lists, but for example, I can just change this to a round bracket and you'll see that it will still work. This works for tuples. So there we go. Another one is all. I'm not going to do a quick example. Well, sure, I could just do a really quick example where you can see that if you use the all function, it's kind of just the opposite, where it requires that all of these be true to return true. So since it wasn't true, nothing printed out because I didn't have an else statement. Let me just add an else. So because only one of them was true and not all of them, it was false. So it went to the next statement in the if statement. So another method we have here is the enumerate. Enumerate, I think we might have looked at it in a previous video, maybe not, but it's very handy. Basically you have, let me say I have ls, okay great. So let me say ls is equal to abc explicit strings, literal strings. So what the enumerate function lets you do, actually let me just say, what's in my tuples there? Sure, this works. So again, in the vein of you looking at tuples right now, so what the enumerate function does is it creates an iterator object. So let me do enumerate tuple. Now it says enumerate object. The enumerate object is an iterator. So to iterate through it, we can actually, when you have an iterator object, if you cast it into a list or a tuple or some other sequence, it will simply enumerate, it will fully be iterated through, and all of those different values will be assigned to those elements. So if you do list enumerate tuple, and we'll have a list of the outcome. And just before explaining that, I'll actually do a tuple instead, for the sake of following the tuples in this video. So now you see the only difference is the round bracket versus square bracket at the end. So the enumerate function took each character from our input. Our input was an iterator, an iterable rather. So it took it iterated over the iterable. So it went through each of these characters. And then for each of these characters, the enumerate function spits out a tuple, which has just a ID number. So it counts from 0 and counts an ID number, and it assigns it in sequence to those things that it iterates with. So it went 0 C, and then it went 1 H, 2 E, 3 E, 4 S, etc. So you see now by casting the iterator object from enumerate into a tuple, I have a tuple containing many tuples. Each of those are immutable, as we talked about earlier, and etc. So what you can do here is it's not just with strings, it's the enumerate function can be assigned to any iterable. So for example, let's say you could kind of nest this. Let me do this. Let me say apply an enumerate function to this one that we just created. And I'll just make this into a list. And now you can see it took each one of those tuples we had, 0 and C being 1, 1 H being the next, etc. And it assigned, once again it did an enumerate, it assigned a 0 to 0 and C, a 1 to 1 and H, a 2 to 2 and E, etc. So just to mess around with this, we could do a reverse. We could say sorted, I'm going to sort this tuple, and we saw the sorted function last time around. And I'm going to say reverse is equal to true. So I believe what just happened. Alright, it's not playing along. Now I'm wondering why. I think I could do the following. I'm going to add a method here to my tuple. I'm going to add the method of reversing it. So dot reverse on the tuple. Alright, so it says tuple. Oh, tuple object has no attribute reverse, of course. Okay. So I just tried to reverse the tuple, that doesn't work. In any case, I tried to play around there, it didn't work. Part of the learning process. But you can see here the idea was having nested enumerations. So that works. Something else that works on any sequence object, including both lists and tuples, is the filter function. So filter constructs, I have it here, constructs an iterator from the elements of an iterable for which the assigned function returns true. So for that, let's just hop over into our more friendly environment here. Let me do filter.py. So now let's create a function where find function, I'm going to make it greater than 5. And I'll say this just takes x. I'll add a string returns true if now let's just say if x greater than 5 return true, else return false. Now I have a function, we can use this in the filter statement. So let me just make a tuple, so let me say tup equals 1. Let me just make this actually cast a range object into a tuple. So range from, it's going to be from 0 to, let's just say 20. And now, having that, I can say tup, or I could use the filter function filter. So you see it says we need to apply a function. So I'll say the function is greater than 5. And iterable is going to be tup. And we can leave that there. And now, let me just go and let me just say to print this out or to store this. So I'm going to print that out. And when we run this, I see. So this creates an iterator object. The filter function creates an iterator object. So when I printed out an iterator object and it just says filter object. So instead I can, for example, cast this as a tuple. Again, we saw this before, you can cast an iterator object as a sequence, and then it'll be a sequence. So now we see here, it filtered out all the values that were less than 5. So if I wanted to do something, well, I could just leave it there. You get the idea. So the function could be a custom function, or it could be something else. We could say, I could just make this a lambda function. We've seen lambda functions before, so I could say lambda x, and my function will be actually, never mind. I'm not sure if a lambda function would work so well in this case, but it'll work in a map function, which we're about to see. So I'll leave that there. There's not many default functions that can work here because it needs to just simply be a true or a false output. So moving on, there's the max and min. So let me just see, what did I have here? So let me make a new tuple. Tup equals tuple range, and I'll make that go up to 20. And now there's the basic max function, so max tup equals 20 equals 19 rather, and min equals 0. Very basic. It just pulls out your max or minimum value from your list or tuple or whatever you have. That works with alphabetical things as well. So if I say tup equals A, B, A, B, then max tup returns BB, and min returns AA. So it kind of goes by alphabetical ordering. That didn't have to be in the order that it was. I could say tup1 equals, I could just change the order there, and I'll just say that's equal to tup3, tup1, tup2, 0. So we see now they're out of order, they're a different order, but if I do max tup1, it still returns BB, and if we do min, it still returns AA. So that just goes to show that it follows the alphabetical ordering for max and mins. Then there's a map function here. So the map function is really handy, and what it does is it returns an iterator, which goes over the iterable that you had to put in, and it gives you the result of having passed each element of that iterable you put in through the map function. So here's an example. I'm just going to make a new file over here, and I'll say mapper function .py. So mapper function, we'll just say that this is actually going to give us, its output is going to be something like this. Its output is going to be the tuple with some value x and then sign x over here. So that's going to be our output, and it's going to be for a large value, like a number of values of x. So we can say, first of all, just create our inputs. So input can be a tuple, by tuple, range from 0 to 20 or 19, whatever the case. So there's my input. Next we can say I could import math. So that's a library where I have the sign x function, and I can do it as m. So I can refer to my math library with the m character. So without importing math, you can't use the sinusoidal function. It's not in the language. So having that, now I can say my sign x is equal to, it's going to be a tuple, and it's going to be the outcome of mapping. So I'm going to do map, and the function now is going to be m.sign. I'm passing in the function without an argument, just the function. I'm passing in the iterable that I want to apply all the values to. So that's going to be input. Now sign x. Let's just see what it looks like right now. So we can see sign x print out sign of 0, which is equal to 0, sign of 1, 0.84, sign of 2, 0.99, 0.909, etc., etc. So there's all these values for sign x. So now we had already talked about how tuples are immutable. So I cannot add these two data points together. That wouldn't work. But what I can do is, now this is a good time to show an example of another function, which is the zip function. So the zip function takes two iterables and basically puts them together into tuples, where it puts the values of the same index into tuples. So the first index value from each input will be put into a tuple. So we'll just see the example. So I'll say output equals, say output equals zip equals list. The zip gives an iterator object, so I need to cast it with a list or some other sequence to be able to print it out. So I'll zip, and I will zip two iterators, so that's going to be my input and sin x. So now let me see what happens when you print output. So now output printed what we expected. It's a list where you have a tuple here, 0, and that for the input, and then 0, the sin x. And then another tuple over here, and there's 1 as the input, and 0.8414, etc. sin x. So now what we can do is, now I'm interested to see these ranked from highest to lowest, or lowest to highest, doesn't really matter, in terms of the sin x value. So one way we could do that would be to, let's say, we could do the sorted function. So the sorted function sorts according to, well, you can't sort lists or tuples because there's multiple numbers, so it doesn't make sense what to sort. So instead we could create a function which tells us why we want to sort by the second element. So here's what I'll do. We'll say define result return second element, and we'll just take iterable as the argument, iterable arg, or we'll just say my it. So now let's say we simply say return my it 1. So now we want it to sort by sin x, so we'll just say sorted list equals list. Now the sorted function returns an iterator object, so we'll cast that into a list. So sorted, now key equals return second element, and reversed I'll leave that where it is. Actually, I think this should work now. So let's see what happens. Alright, so it looks like we got an error. Name sorted, not defined. Oh, I didn't add the iterable that we're sorting. So what we're sorting is output. That should maybe fix it. First thing, we're sorting the output by the second element. Alright, still not working. It says sorted, not defined. Oh, perhaps I might have. Yeah, I think because I had a capital S. Always watch out with that case sensitivity. Awesome. So now we see our sorted list where it's sorting them by the second element. So we see 0. Whoa, this is a mess. Let me comment out this other stuff, this other print statement, so we know which output is which. It's messy. We'll run it again, print that out and see what happens. Oh, I didn't print it out. Sorted list. Embarrassing. Go. Alright. So this seems like it works. See, now we have a list where it's sorted in sequence of the second item, lowest to highest, for the second item in every tuple that was a part of our original list that we inputted. So now you see the first numbers, which was the input to the signX function, are all out of order. It goes 11, 17, 5, 4, 18, 10, etc. So that's pretty interesting. So that's a zip example of the zip function in action, where we saw how we could put things together, and then the sorted function, and how we can create a custom function which just returns the second character. I wonder if we could have done that with a lambda function. Let's say key. We could try it out. Key. So it's simply going to be lambda x, and the x is the list, the tuple object that's being passed into it. So it's just going to return x1. And obviously, let's see if this does the same thing. It looks like it did the same thing, so that's really cool. So that's another trick in the bag. The last thing I'll mention for this video is just the simple sum function. So if I have a, let's say, what was in here? ls, I had abc. What if I try tuple? What was my tuple? Okay, let me just say tup equals 1, 2, 3, 4, 5. And if you just do sum tup, you get 15. So another thing we could try over here is we could say sort them, but sort them by the addition of their two, sort these tuples from lowest to highest by the addition of their parts. So we could say x, we could say sum x. And so x is an iterable, it's a list, so that should give us maybe a slightly different sequence. So it looks like because I added sum x, I didn't close the variable, I didn't close the bracket properly. Okay, so I'm seeing some very slight differences here now in the ordering. Here we had 9, 13, 15. Now that's 9, 10, 11. So we see there are differences, so our mapping function worked. So kind of a long video there, but basically there's all your tuple functions as well as a bunch of functions which are generally applicable to any iterable, such as any sequence objects such as list, tuple, and perhaps some other types. So hope that's helpful. Really important subject matter here. Feel free to support me if you like. Take care.